There we are. All right. Hello, everyone. Welcome, welcome, welcome. Today we have the final day of RustLab for you all. My name is Latara. I'm the talk manager for RustLab 2020. So right now we have for you a talk by Yosh, and it's called Designing Tide. So let me welcome Yosh to everyone. Hello there.
Hey,
Hey, it's great to have you here. Thanks for coming.
thanks for having me.
Yeah, we're really excited to have you. So I'll read your bio really quickly, and then we'll go ahead and start with the talk.
Sounds good.
Okay, so Yash here is the former co-lead of the Async ecosystem WG, current member of the Async Foundations WG, co-designer of Async STD, and co-designer of the Tide framework. Oh, much of his work in the past few years has been focused on async Rust, and he will give a talk on API design in the context of async Rust. So in this talk, we'll talk about async networking, how it is taking off in Rust. One challenge in particular is how to make async Rust available to existing and new Rustaceans alike. So in this talk, Yosh will walk you through the design of Tide, a friendly HTTP server, using it as a case study for effective async API design in Rust. So we'll go ahead and get started with that. Thank you so much for being here.
Thank you.
All right.
All right. Hey, everyone. Welcome to my talk, Designing Tide for RustLab 2020. If you're watching this, hi from the past. I think it's about 2 weeks ago now. You should be watching this on a Saturday, if I got it right. Hope I got it right. Anyway, hope you've been having a good week, and I'm excited to be spending a little time with y'all. So yeah, my name's Yosh. I'm a Rust engineer at Prisma. We do database things. We build a variety of interesting database projects, primarily focused on TypeScript, but also Golang, and all these things are backed by Rust. So yeah, I work on the Rust part of it, on the Rust team, and our team builds various database drivers, SQL, interesting things there, lots of networking going on. So yeah, that's quite cool. But today we won't be talking about any of that. Instead, we'll be talking about Tide. HTTP web server in Rust. So first off, let's cover what is Tide. Then we'll cover the design of Tide, some of the considerations that went into it. Then the concepts and features, not necessarily things that are unique to Tide, but I think the combination does set Tide apart somewhat. And then finally, a demo after we have a brief break. So yeah, I think you should be able to ask me questions in the break. I'll be around. If not during, then after. So yeah, cool. So Tide is a HTTP web server that's part of the HTTPRS organization. Our two flagship projects are the Tide web server and the Serve HTTP client. And together they can be used to, for example, build something like a proxy server where requests come in and you make requests back, and a response comes back from that and you forward that again. They're not necessarily intended to be used together, but you certainly can, and it should be a fairly consistent experience. But yeah, today we'll be focusing on just the Tide part and some of the layers that work under it, but Serve is very similar. So yeah, one of the things that is very specific, not specific to Tide, but Tide was one of the first HTTP frameworks to work with async await. We used to have a thing called the networking working group as part of RustLang working groups. I used to be involved with that, and Tide came out of that as a project with the intent of let's find out to which degree async await is usable, what's missing, are we on the right track, what needs changing, help inform the whole design process around it. a project was started, and obviously like a HTTP server was a use case that sorry, I'm trying to find my words there. Was like a use case that was very much at the front of people's thinking when building. Academically exist. We also like wanted it to be usable and like nice to use. So one of the features, like we very much like built ergonomics out, etc. But one of the key things for Tide is it has a very minimal feel to it. So like getting started should be very similar to projects such as Koa Express in Node.js, or like maybe Sinatra from Ruby, I believe. What's the other one? Flask, Python. They're all like in this realm of like very minimal frameworks, and at the very least, like Tide should feel familiar if you're coming from there. But also we want it to be like rich in features, so probably expanding beyond what some frameworks do. We do want to provide like solutions for very common tasks that you do in HTTP. But yeah, sort of like packaging all that together is like the base requirements where Tide came from. So yeah, if you want to try Tide out today, likely you'll want to write a hello world. This is what that looks like. So at the top, you have your main function. In this case, it's async fn main, courtesy of async stud main, which enables it to be async and like await futures. So you get to use async await instead of this. Then it returns a result. But yeah, which means we can use a question mark and error handling, etc. Inside of it, we instantiate a new instance of Tide, which returns a Tide server. On that server, we say on the route / for the HTTP method get, return hello world. That's a closure here, and it returns a future of a result of hello world. And that gets converted into a 200 OK with just the string hello world. Content length exactly to the string length, etc. And then finally, for application, our little server over here, we say listen on localhost 8080. If we run that, if we run that, you curl it, you'll just get hello world. I guess I didn't add a slide where it curls that, but a slightly larger example of this is one where we try and actually parse some data that comes in as JSON. So the way that works is we define a struct called animal, which takes two values, name and legs. Name's a string, legs a U8. We implement deserialize on it, which comes from Surdy JSON, which comes from Surdy, which is included through the prelude right here, just as a convenience. And then inside of our main function, instead of like for the route /, we define here a different route, /orders /shoes. And then we use the post HTTP method, which takes the order shoes function as a callback and invokes it every time that route's hit. Then, like in the previous example, we listen on localhost 8080. Now, if we curl this route, if we hit this route, then what happens is we receive a request and we return a result of a response. This is a type alias with a default param of Tide response, so you don't need to type it out. This is just for convenience. But yeah, takes a request, returns a response. That's the base model. So in here, we say parse the body as JSON in the shape of animal through type inference. It knows how to parse this, and then either return a result, return an error, or give us back the name and the legs field from this animal. And if that succeeds, we return back a little string that says like, hi, I've put in an order. Ooh, I think a cat might jump. So if a cat jumps into the screen like mid-presentation, that's the thing that might happen. Yeah. So if we curl /shoes and we give it a name of Chashu and legs 4, Chashu's my cat, different cat than the one that's about to jump. That's naughty. Hope she'll come into frame. She'll say hi in a sec, maybe. Then we'll say, hi, Chash, I've put in an order for 4 shoes. Now, if we take a different order, say for Mary Millipede, who has 750 shoes, we'll see that we get back an error saying number too large to fit in target type, because 750 doesn't fit inside of a U8, which we've defined up there. So that's Surdy being like, hi, here's an error. And this gives us like the basic like type level validation that at least, once we get past the HTTP boundary or, past the JSON payload as well, then we're just working with like actual valid data. And we have a pretty strict assurance of that. It's not too hard to define, hopefully. I hope that doesn't look too daunting. Yeah. So design considerations, like I mentioned earlier, we have a very strong focus on ergonomics. We really want Tide to be very nice to use. So we try and talk to people, figure out the patterns people are using and try and improve on that. We're also very aware that, Tide being an HTTP server, it may very well be people's first, not only experience with async Rust, but like Rust in general. People coming from Node.js, like myself, instinctively, one of the first things you want to try in a new language is to be like, oh, cool, let me write a quick little HTTP example, see if I can create a small network service. That feels very natural. And so, Tide being pretty lightweight, being pretty easy to pick up, likely will be people's first experience in Rust. And as part of that, we have a bit of an obligation, I think, at least we make it part of our constraints, to make sure that we feel as consistent as possible with the rest of the language, with the standard library, with the existing ecosystem. Just so people don't run into, oddities where they're learning Tide, right? So they learn Tide and then they try and use the rest of Rust and they don't recognize it. Instead, by learning Tide, you should be able to learn the rest of Rust. It should flow naturally out of that. If not currently, we're definitely wanting to be doing that. So yeah. And finally, we realized that Tide, like any framework, while being convenient, while being able to provide a lot of assurances, while, however well designed it might be, at the end of the day, it's not the end-all solution for everyone. So pretty much everything in Tide is built up from lower level components, standalone components you can use yourself. So yeah, we try and split that out. Speaking of, the way this works in Tide, the way our layering currently exists, is at the very bottom layer. So Tide as a project exists on various layers. At the very bottom layer, we have a runtime, async stud, so you can swap it out, which provides a way to do networked I/O, to do async tasks, spawn them, schedule them, multi-threaded, all the stuff. Async stud is responsible for that. Then on top of that, sort of throughout the whole project, we have a thing called HTTP types, which provides structured types for all the HTTP idioms, not just things like this is a URL or this is HTTP status code or method, but also things like this is what a content encoding header looks like. So you can parse and serialize and all the things. Because we think it's important to provide structure there so people don't stringly type programming isn't ideal. And this prevents a lot of mistakes. And having just a shared idiom for all things HTTP is very convenient. So that's sort of the glue between the framework layer and the underlying libraries that power it. Async H1 is our HTTP 1.1 parser serializer, and async TLS is our TLS implementation. So this is what HTTP types looks like. Also, async TLS, we actually have two TLS implementations, one that's for the native TLS module and one for Rust TLS. We're trying to converge them, so I just wrote down async TLS here. So yeah, HTTP types, if you look on docs.rs, this is what you'll see, a whole bunch of types. There's even a little bit of an older screenshot, so we have way more submodules now and all the things. We're trying to build out, like I said, the full HTTP idioms, but typed. Async H1, similarly, this all works over the std future stream. So you give it a async read in, I believe, and an async read out. It'll parse it into HTTP, so you get back essentially a loop that just gives you request response. That's not quite a loop; it's a callback. You can't see here. This is just the client, but we you give it a stream and converts it into HTTP. Similar with async native TLS, you might be able to see a bit better here. You give it a TCP stream, and now it's an encrypted stream. As the client part, server part is very similar. So yeah, layers everywhere, components everywhere. We quite like it. So yeah, say we're like, so here's a bit on the design process of Tide. Say we're introducing like something new, like a new feature, a new protocol, something that exists but we don't have an abstraction for currently. Like the very first thing that we try and do, the very first thing is we try and understand what it is that people are trying to do. But if we find there's like a RFC for it, like a IETF, I believe makes the RFCs, I forget. But like if there's an actual like spec for this thing, then it's very straightforward to like just start by writing a protocol parser. We implement a protocol parser, and then we move from there afterwards, like a parser encoder, basically. Then after that, we move to build a Tide extension. We try and see how we can integrate this into Tide itself. What is a good API here? What are the considerations? Because just parsing the protocol oftentimes doesn't encode like other things, like if an error of this kind occurs, then you need to convert a status code of this kind of thing. Or if, there's a variety of things that aren't like just covered by the parser itself. So we try and build an extension that covers all those cases. And then finally, if we have that, then the thing we can do is to create a first-class feature. So maybe like integrate directly into a framework, maybe integrate directly into a framework behind the scenes, add dedicated APIs for it. We get to investigate that. So for example, compression, right? At the base layer, the protocol layer, what you need is zlib bindings, and you need accept encoding, right? Like a parser encoder for accept encoding. Now with those together, we've taken like both of these. There existed like libraries for it, like zlib. There was a synchronous version, and then that got to be configured in a particular way. And now async compression exists, which is an async version of zlib with some other stuff with it. Then Tide compression combines that and a structured accept encoding parser encoder, which is part of HTTP types again, and combines it into like a single middleware that you can just plug into Tide. And then the final step in this process will be, did you hear that meow? It's my cat again. Oh my God, she doesn't want to jump. She's very sleepy. Come on, Naughty, make an appearance. Yo. Yes? Yes? Come on. You can keep talking. Yeah. Oh. All right, let me go off screen. One sec. All right, I guess not. She doesn't want to. She thought about it for a sec, but then didn't. Anyway, we'll see her jump in a sec, I think. Where was I? Built-in compression. Yeah. So, even better than like any of this is if we could just, be like, oh, Tide supports compression. When does it do it? All the time. There's a cat. It worked. Hello. Do you want to say hi to the camera? Oy. So say hi to everyone. This is Naughty. Yeah? Okay, no. No. Oh, she pressed the space bar. That moves it to the next slide. So yeah, built-in compression. If we just have it on all the time, then no one even like needs to think about it. So yeah, that brings us sort of to the next point, which is flows. Right. When designing anything, I think this is a pretty interesting like distinction to make. Actually, I stole this slide from Yehuda Katz's 2013 RailsConf talk on Rails the next 5 years. I think it's very worth a watch. And like he has this fascinating like thing about like design in there, which is basically this, which was he makes the point of like, if you want to like do anything, right, then inside of like the context of a framework, then the maximum amount of effort you can expend is if you need to do it manually. Manually means either finding a library that does it for you and figuring out how to hook it up, or maybe even like realizing there is no library for your use case and you need to manually write an implementation, then test it, then like verify, iterate, all that stuff. It's just a lot of effort. And, it's the maximum amount of effort you can expend. Now, say we had like just a plugin for the thing we're trying to do, like a semi-automatic solution. There's part of a solution here. then, that is still effort, but less, right? But then, if we compare it to an automatic solution, then the amount of effort expended there is actually 0. It's the minimum amount of effort possible, right? If we take compression, for example, compression. Sorry, I lost my words. I was thinking about my cat. Compression, if you need to create zlet bindings yourself, it's a lot of effort. If you need to use a compression plugin yourself, you need to be aware of what compression even is, right? But not just that, you need to also realize when it's enabled, you need to understand the parameters, you need to understand all the ways that compression should or should not be applied. And then make a decision, right? And in many cases, understanding the problem is half the work. The implementation itself is not the hardest part. Fully understanding the scope of the problem, that's a lot of effort. But if the solution is automatic, then it's just taken care of for you, and you don't need to learn about the problem in order to make a decision on a solution because it has been taken care of for you. Now, I think a key insight there, though, is that we cannot automate everything away, right? At the end of the day, a framework is just that. It is a framework to do something within. And some of the tools, if you add them, they can be sort of hard to unadd them later. So you need, careful decisions need to be made about what is or isn't provided. In some cases, having an automatic solution is not the right way to go. Having something semi-automatic is better. Or maybe, a problem is poorly understood and just telling people do it manually is a better way. But yeah, we can't automate everything away. But what we can do is we can design flows that feel good. So say we know a common use case for Tide is as an API server, we can provide guidance into how to achieve that, and over time iterate and polish that flow. If we know people want to use Tide as a proxy server, then again, we can guide people in achieving that. Yeah. I have a very dry mouth right now. I don't know. So I'm drinking water all the time, but it doesn't seem to help, so I don't know what's up. Yeah. Concepts. So that's a bit on the design of Tide. I guess summarizing, we can design flows that feel good is probably a good summary. I don't know. Concepts. Request response. So one of the main things that Tide does, and I think does throughout the whole application, we intend to keep doing forever, is have a notion of request and response. So its basis, request goes in, response goes out, right? Request, response. Now for HTTP multipart, we don't have an abstraction for this yet, but we try and fit this into the HTTP or into the request response model as well. So in multipart, a request goes in and then a response goes out with multiple bodies. For HTTP2 push, push frames, a request goes in and multiple responses go out, right? So it's not just one response, we send multiple back, and then in the future when a client wants to make a request to some of the responses we've already made, they already have the response ahead of time, which is pretty interesting. HTTP upgrade, a request goes in, and we switch to a new protocol. We say oh, cool, you want to switch to WebSocket? We support WebSocket. We now speak WebSocket, right? Again, request response, and then we upgrade. Chunked is pretty interesting. So every HTTP request needs to know its length ahead of time. And if it doesn't, you can delimit it. You can frame. Is that correct? Yes. A request goes in and a framed response goes out. So you send chunks and you say oh, this is a piece of data, this is a piece of data, this is a piece of data, and now we're done sending data. In turn, H100 continue. This was a really fun one because we didn't know about this initially, but only found out after people made us aware of this. So this is for large requests. Let's say you want to upload a couple megs or a couple gigabytes of data. You can verify that the headers are correct before sending the request body. So in this case, request headers go in, We send a response back out that says 100 continue. We verified the headers, everything's good. Then the client says, okay, cool, here's the response body. And once we're done processing the body, we send back a final response that says, okay, 200, okay, everything correctly accepted. And then finally, we have service and events, which basically a request goes in, and we keep the request open. Or, yeah, we keep the request response pair open. We send back a response, and then we just keep sending messages as the response body forever until we decide it's time to close. We send keep alive, like the little status update. What do you call them? Heartbeats? Yeah, so it's like a very long response. Kind of like long polling back in the day, I guess. Is that true? A little bit different, but you get the idea, hopefully. So yeah, concepts middleware. So Tide, one of the ways we allow extending Tide is through middleware. The way that works is there's a method called app.with, which takes a middleware, and every single request that goes through it will pass through this middleware. Oh, my mouth is really dry. I'm sorry. So yeah, the way a middleware is defined is like this. So here's a async fn log, which takes a request that goes over state. And so it takes a request and next param and returns a result of a response. So in this, we receive a request and we send back a response or a result of a response. So in goes a request. We say, hey, we received this request from this URL over here. Then we call the next middleware in the chain. We give that the request. And in turn, that calls the next middleware in the chain, et cetera, et cetera. At the end of it, we get back a response and we send that back up the chain again. So in this case, we read back the status code from the response and we log that out. So visualizing it, request goes into a middleware, into a first, second, third, and finally goes to an endpoint. The endpoint constructs a new response, and then that gets sent back up through the middleware chain again. So yeah, state is another concept that's that's like central to Tide. The way that works is we enable you to have shared mutable state, like for example, a database connection. So the way that works is Tide is generic over state param. You can populate with whatever you like, and then that is exposed on request.state. So in this case, you can see we're initializing a MongoDB database. We connect to it, and then we get a single database, like a single table? Like a single, database in this case. And we pass it to application, just as a param. And then here, our index function that we're calling here on the slash is generic over the database. And we get a collection from it. And then we say, cool, here, increment the counter by 1. And then we're like, oh, here's the ID. Is that accurate? No, we just add a new record with X is 1. That's fine. We insert a record. Just as an example, it doesn't really matter. So yeah, features nesting. So another cool thing that Tide enables is nesting of applications. So say you're on your way to create microservices. You're building a monolith initially, but you may eventually want to split things out. You can build it as like nested apps. Even in separate crates if you like a monorepo style. So yeah, Tide allows you to define multiple applications and nest them through the .nest method. So in here you can see we're defining API service, 2 routes, hello and goodbye, hello world, goodbye world, and then our main application over here, which has 1 route just on the root, which says root, and on /API, we nest the API service, and then we list on localhost. And now if we run that, then if we curl the root, we get back root. But if we curl /API/hello, we get back hello world. And then API goodbye, goodbye world. Yeah. Then another thing is redirects. I'm getting cat meows. People are hungry over here. Yeah, I'll tend to them in a sec. Inline redirects. Redirects. Yes. So features redirects. Tide supports, redirect's a very interesting one because we support redirects in two different ways through the same type. So either as an inline redirect, where we say, hey, here we have a route handler of something, and we say redirect new, and we convert this into a response, and that will redirect to this product URL with a temporary redirect, I believe. It also has like a dedicated endpoint. So it also implements Tide endpoint. So you can just be like, on route / use Tide redirect permanent to forever redirect to example.com. There's a cat behind the green screen here. It's just meowing. I don't know. I know I'm breaking the fourth wall like several times, but yeah. Such is the life of a single parent, I guess. Yeah. Meow. All right. Almost done here. In the future. So yeah. Do I want to say anything more about this? I don't think so. I think it's interesting that, the same type can be reused in multiple different ways. It's a pattern that a contributor came up with and that we really, really like. And we might use for things like asset serving, etc. So yeah, we're trying to figure out ways, or if we can use this in more ways. So yeah, in the future, things we might add is, for example, file storage. When investigate hey, is there a good solution for file storage? Maybe as a separate project, maybe as a, maybe not. Things around the internal channels. We've been looking at Phoenix. We've been looking at the Rails job queue. I suspect that there might just be something there that covers all of them. We're not too sure yet. But yeah, email is a very common thing. Transactional email. We need to have some sort of solution there, or we'd like to find one where people can make it easy to send that. Things like graphs. People use GraphQL, JSON API. They're all graph-based, object-based API creation. What can we do there? What can we do there to make it easier? So yeah, that's in the future. If you'd like to check out more from Tide or Surf, you can find our HPRS, and there'll be a demo after a break. And I think I'll be taking questions now. All right, that's it.
All right, you all, we are going to take a 5-minute break now. So we'll be back at, let's say, now it's 13. So let's say at 18 past the hour. And we're actually going to save Q&A for afterwards. So please direct your questions to the Q&A chat. We have one question there already. So see you at 18 after. Thanks. All right, everyone, we are back from our break, so we're ready for the second half of the video. Enjoy and see you at the end for a live Q&A session with Yosh. Thanks.
All right. Hey, everyone. Welcome back to the second half of my RustLab 2020 talk on Tide. Here we're going to create a little demo application with Tide. So what we're going to do is we're going to create a simple little basic auth login system that hooks into Tide's session abstraction. So we get someone to log in using basic auth, and then we validate the username and password. And if it's validated, we store a user ID into the session. And on repeated requests, we're like, oh, we recognize who you are. We recognize the session, your user with ID X. So I've set up a little basic example repo here. As you can see, we just have a basic little cargo toml. We're importing async state here. With the attributes feature enabled to get async if main working. We import Tide, and then we do something a little bit interesting, which is we apply a little patch for HB types on the basic auth branch. So what I did is a couple days ago, I started working on creating typed headers for basic auth and other like authentication related headers. Just for his demo. So we haven't merged it quite yet. We still need like reviews on it. We need to make sure everything's good. But I wrote it for the demo, so I wanted to use it here. I expect we'll get it in a very similar form or shape. So you'll be able to use this soon enough. All right. So here we have the main binary file. So we've defined a little entry point called async if main. Here. It returns std.io results. We applied the async std main, so we can use async inside of this. It's nice and easy. So what we're going to do is we're going to go ahead and create a new Tide app. So let new app is Tide new. Then we're going to define, we're just going to make it listen on localhost. So app.listen. 8080 dot await. So that's the basis of our application. Then what we're going to do is we're going to register a little login route. So we're going to have like on either slash or slash login. So app.at slash, let's go with slash dot get, and we're going to give the login function, which we've defined down here. We just commented out real quick. And we need requests for that. So yep. There we go. We've just defined like this. And now if we run this, then we'll get an app that listens on localhost and has a single route defined. That doesn't do anything. It'll just panic. All right. So next step is let's enable logging. So Tide log start. That sets up a logger that just listens for all the logs. Then we'll print them out to standard app. Then what we want to do is we want to enable the session middleware. So every single request that goes in and out of the application will have a cookie associated with it, and we'll be storing that cookie inside of our session store, just recognizing it, keeping it around, but not authenticating it quite yet. We do that inside our route. So app.with session store. Hold on, we need to comment this line out so we get autocomplete. Session middleware, new, session or memory store, new, and then we give it a secret. We also have the secret defined here. It's just some random data. It needs to be 32 characters, so we just said shh. Now we've defined our session middleware, which handles all session stuff. Right, yeah, that's good. All right, now we can proceed to fill in the login. So let's start with the success first, where we say, okay, logged in. Yeah, if someone made it all the way to the end of this, we just like, hey, congratulations, you've been logged in. You've logged in. Good. So first things first is we want to make sure, like, we want to check if someone's already logged in. If someone's already logged in, we don't need to take any of the other steps. So the way we do that is let session request session if let some doesn't matter what it is. If we have a value for user ID, session.get string user ID. Then what we say simply is already logged in. Ta-da. All right, nice and easy. Second step is, okay, if someone isn't logged in already, then we want to check if the credentials are being sent down. So the way we do that is we use the basic auth header. So let auth equals basic auth new from headers, because we want to get it from the headers. So in this case, it's and request. And this will return a result of option. No, we can't. Okay. So some auth, or in the none case, we want to request the person to fill in the tokens. Oh, this needs to have a match in front of it. Like that. All right, great. So we get the authentication. We get a username and password extracted from the basic auth, from the authenticate header. And in the case that that's not the case, we want to send back like a www authenticate, like, hey, and tell the browser, like, put the prompt for the login stuff. But we'll fill it in a second. Let's proceed here. So what we do next is we say, like, okay, please try and log in then. So validate the username and password against credentials. In this case, we're just going to hard code the credentials. We're not going to do any hashing. This is not the way you would do it for anything real. This is just a demo. We'd also store this in a database, get this from a database somehow, you know. So we want to have ensure here, which makes stuff easier. Ensure eq. So what we do here is auth.username equals username. If not, return 401. Wrong username. Same for password. So incorrect. So we use some better language there. Incorrect username, incorrect password. Great. Now, if these two checks have passed, then the username and password line up, which is great. Now, in that case, likely we were able to get a user from a thing, the hash password from the database as well. We would also know the user ID at this point. So, you know, we just hard code it in a string for now. We're just going to add the user ID to the session. Then we get the mutable session. So let session equals request.session mute. And then session.insert user ID, and then user ID. Like that. Oh, we have a little error. Oh, request needs to be mutable. So let's do that. And this returns a result. So this can fail. There we go. Now we successfully check if a person's logged in, then, you know, get the credentials, try to log in, save the session, and then send a success message. Now the final part is, in the case no credentials have been sent, please ask for credentials. So the way we do this is using the www deb authenticate. So let auth, or actually let's auth is authenticate new, which takes a scheme and a realm. So let scheme equals authentication scheme basic. Let realm equals some string, which in this case we say like login to the example mainframe. right? Now we have this response. We're going to create a new response equals response new 401 because we want someone to log in. Auth.apply and mute res because we want to apply the headers there, and then we return OK res. Realm to owned, I believe it needs to be. Oh. Ta-da! OK res. Oh, we need to return. There we go. Okay, great. Now, in the case someone's not logged in, we'll ask them to please log in and prompt the browser to like show the little thing. So we can cargo run this, no compilers, as you can see. Then we can open this on localhost 8080. Because of reasons, we need to open this in a private tab for now, so we actually see the prompt and the browser doesn't remember stuff. Localhost 8080. Username is Mori. Password is I love fish. Enter. Yay, you've logged in. In the network. So you've logged in means success. Successfully logged in. Now let's reload the page. And then if everything's good, we'll see like already logged in because it's a known user on a session. It's like logged in. So we do this and it says already logged in. And we see here, if we open this, oof, oh, interesting. Oh, yeah, good. Cool. Then that works. See, we've like hit the route a couple times, and every time it says like, hey, yeah, we know who you are, you're logged in. It's all cool. Yeah, and that's how you do basic auth in Tide. Almost, kinda, in the future. We need to land a patch for HTTP types, and likely when we have the patch, we can simplify some of the logic here down just to the part where we ask someone to get to just validate the username and password against some database. We can simplify this down, but you've seen the way session middleware works. You've seen how to create a memory store to back it. You've seen the logging here on the right-hand side. Hopefully you get a bit of a sense of like what an endpoint looks like. You could imagine like replacing this with business logic, some other stuff. We have the request going in, the response going out. Yeah, I think we've covered quite a bit. Hopefully this gives you an idea of how Tide works. Yeah, thanks.
All right, everyone. Hope you enjoyed that wonderful talk by Yosh. We're going to bring him live in just a moment to answer some of your questions. Let's see here. Yosh, I need to be able to turn on your camera and microphone. I can't do that. Can you check it, please? Okay, there it is.
Hey.
Wonderful. There it is. Oh. Wonderful. You made the talk very interesting with the appearance of your cats. Thank you for that. All right. Well, I want to say thank you so much for your contribution to RustLab. Even if it's not in person this year, we're still very happy to have you. Also, do you have, do you have anything you wanted to add or say about your participation in the event?
Oh, sorry, my cat just laid down on my keyboard, so that's interesting. No, I'm really happy to be here. I've really enjoyed the talk so far. I attended last year in person, and I'm just glad to be able to be here.
Awesome. Awesome. All right. Well, we'll go ahead and get right on to our questions. We have two from, oh my gosh, I am so bad at pronunciation. Dolgopolyo. I'm so sorry. We have two questions by this person in the chat. So let's proceed by answering the first question here, which is, what is the status about IR Uring in async stud ecosystem?
Right. So for people who are not too sure, like this talk was about Tide, which is the HTTP project that I work on. Async stud is the async runtime that I also work on. Tide uses async stud. And the question here is about IOU ring, which is a particular Linux kernel API for very fast IO. It's rather new. So currently, async stud and in turn Tide do not support it out of the box. But a good friend has a library for it called Ringban, with another library attached to it, which is called IOU. And both of those are very similar to the way Async Std works internally. And we've been discussing with the core team of adding a feature flag, an experimental feature flag that would switch us over to use IOU Ring if it's available. If you're on a modern Linux kernel and we feature detect and you have that flag enabled, then we'll switch it out and use it. It's all like very new APIs and the libraries are very new, so it's a bit of a question like do we how much do we want to support it? But we definitely want to start experimenting with it, and the base, the core layers already exist in the ecosystem. Hope that answers that.
Awesome, thank you. All right, next question, also from Roman, I'll say. He says, as soon as it is more about design, is there anything in other frameworks that you liked and would add to Tide from the box?
I think that's a really interesting question. Thank you. So what from other frameworks would we like to add? So I've heard a categorization in terms of like HTTP frameworks, with more or less splits it into two directions, where one is like micro frameworks and the other one is Rails. I think that's not necessarily the right categorization, but hold on, let me backtrack one sec. I'm obsessed with Rails at the moment. Like, I've been looking at it and seeing like all the things that they do. It's so interesting. They have answers for like, how do you store a file somewhere? How do you send an email? How do you schedule some job on a worker queue? Like, how does all of this integrate within the system? And like that scope, I find very intriguing. And we're definitely looking at like, what can we take from there and maybe apply to Tide? Not necessarily in a very frameworky way, the way Rails has done it, but definitely like scope it up. Yeah. So all the things that go into building a web app, we're definitely looking at like, okay, what are the things that people want to do and how can we integrate them into Tide in like a very modular fashion? Yeah. Awesome. I really like that question. Thank you.
Yeah, it's a good one. Great. While I am waiting to see if anyone else has any other questions here. Nope. Sounds... I have a question for you. Yes. The first... one of your cat's names is Nori. Is that the Japanese word for like seaweed that you wanted to name it after?
Yes.
Awesome. And what about the other one?
Chashu.
Chashu.
Yeah, it's like braised pork belly.
Oh, yummy. Okay.
Yeah.
Yeah. I think
my partner and I really like ramen.
Yeah.
So we named our cats after ingredients.
That's fantastic. I love that. Awesome. All right. Well, I don't think anyone else has any other questions. So I guess we can leave early, unless there's anything else you would like to add.
Oh, I saw one more question, I believe.
Oh, yes. Here it is. Roman says, what is the long-term plan for Tide? What is really not Noi okay from your thoughts? Okay, I think that's not okay. Typo.
Maybe that's like the negative design space. Like, what are the things we don't want to be doing? I can definitely share a little bit on what we're doing for Tide right now. We are noticing that Tide has like really been taking off. Like more and more people are using it. We've been seeing like really big brand names starting to use it in like core infrastructure. We're like, oh, whoa, okay, we didn't expect that. And we've been getting a lot of contributions. And for now, at least in the short term, our plan is to find ways to scale up the team. So it doesn't just become like, oh, it's me that has to review every single aspect of the framework. But we can like get people who are interested in, for example, authentication and empower them to take ownership over that part and establish lines of communication. Like our long-term goal is to like truly make it a really nice to use web framework for Rust that people from other languages can come and use and are not only like, oh, I've heard about Rust, it seems nice, but kind of difficult, but are like, oh, wow, like Tide is actually such a nice framework. I would prefer it over, for example, Python. But yeah, like our goal is very much to scale that up and to get the right people in there and to get their experience with and, you know, get people involved to help design this thing together. Like negative space, I don't know exactly what we want to do there. It's not too decided, but you know, we define things as we move ahead.
Sounds good. Yeah. And the future is full of opportunities. So
Yes.
I wish you good luck for that.
Thank you.
Awesome. All right. Great. Well, I think if that's it, then I want to just thank you again, Yosh, for coming to RustLab. Hopefully, we'll see you in the next editions, maybe face to face. We'll see what the future brings us.
I certainly hope so. Thank you.
All right. Thank you so much for coming.
Bye.
Awesome. Thanks. All right, everyone. Well, thank you all of you for also coming and enjoying this session. It was really great also to have some participation. So I want to also just add really quickly that you can definitely rate this talk on the agenda page of the RustLab site that we've organized this with. And then we'll be waiting for you for the next talk of today, which will be by Cameron Manavian, which is Modern Full Stack with Rust, writing reliable code. So that starts in about 11 minutes, and hope to see you all there. Thank you so much.